All right, EJ Daigle here, Dean of Manufacturing at Dunwoody College. I'm going to do a little lesson on creating and editing ladders in AutoCAD Electrical with PLC IO. That's going to be the goal of this lecture. I'm going to scroll through, actually I'm going to just do it this way. I'm going to scroll through a few of my slides here just to kind of talk a little bit. I'm going to skip this model here and jump right into this. What we'll do is we'll go ahead and insert a ladder diagram in this. And I'm going to show you guys how to insert PLCs parametrically. Go out and grab predefined footprints for PLC modules using AutoCAD Electrical's database of components. I'm going to show you how to do show you that there are some full unit PLCs in here as well that you can take a look at. How to import the individual PLC modules. We'll do this here in just a second, and I'll run this through. How to address or how to tag some of these I/O points that you're going to need to tag. You may tag them both with I/O addresses, but you also might like to tag them with the hardware that's hooked up to them, although that's going to be drawn into the drawing as well. And then how also to go out to Rockwell Automation and under support, find the 2D and 3D drawings that you might want to include on your drawing, so somebody can say, okay, what is it? What is it I'm actually looking for? So if you've got somebody that's going into panel, and obviously finding an Allen Bradley 1769 IQ16 discrete input card may be very easy to do, but at least they have an idea of what this thing looks like in the panel as well. And then finally, we'll add some of these tails in here as well, but finally we'll also put in some individual PLC IO points, which will be handy for us as well too. It's not always, you may not always have access to a catalog database. Maybe it's a lesser known PLC, maybe it's a really old PLC, or maybe it's a really new PLC that's not in the database. And maybe in some cases you don't necessarily care about the physical footprint of the IO module. You might just say, I just want to show the I/O addresses that we're going to and from on my drawing as well. So all of these are possibilities. So just like a normal class, what I'd like for you to do is go ahead and open up AutoCAD Electrical. I've got AutoCAD Electrical open right now. And what I want you to do is go ahead and let's just start a drawing. I'm not going to be real particular about a template or anything at this point. So just go ahead and pick a drawing. So we've got a drawing field that we're going to work within right now. And what I want you to do is I want you to go ahead and start by inserting a ladder diagram. And I'm going to just go up here where it says Insert Ladder. What do we got here? Special block needs to be OK. I'm just going to hit OK. I'm not using my template right now, so I'm getting a little bit of a mess there. I'm going to make my width a little bit wider than I normally would. I'm also going to make my spacing maybe a little bit narrower than I normally would. And I'm going to insert, I'll just go ahead and insert. I'm just going to draw a whole bunch of rungs. Whoa, that's definitely a whole bunch of rungs there. I'm shooting for something like 20 rungs or so. I don't know how many I ended up with here. So we go from 11 to 31 would be 20 rungs. So maybe I'm good with this. Maybe I'll just call this good and go from there. All right, now this is where it's gonna get kind of fun. If you haven't done this before, it's kind of cool to see. What you do is right up here, you've got kind of underneath the schematic tab here, you've got Insert PLC Parametric, and when you click on that, it's going to bring up, you can see where I've been. I'm always in the Allen Bradley section here. It's going to bring up all these different providers of PLCs. So you've got Siemens, you've got all these different Siemens PLCs. You've got Allen Bradley, and you have all these different Allen Bradley PLCs. Just to keep it simple for right now, and you can do these things graphical style, either vertical or horizontal mode. I'm going to do Allen Bradley, and I'm going to do 1769. And I'm going to do the IQ16, which is a 16-point DC syncing input. So I'm going to go ahead and just hit OK on that. So I've got an Allen Bradley. So the nice thing about this catalog is there's all kinds of Allen Bradley modules in here. and I can just go grab them and use them. So I'll go ahead and hit OK. Now it's going to bring in kind of the ghost shape, which shows you the amount of real estate this particular module is going to take up on your drawing, right? Has nothing to do with the physical real estate in the panel. That will be a separate, but that physical real estate also comes over with catalog information. So you get both for free. But what I'm going to do right now is I'm just going to kind of position this X. This X marks the spot, kind of right on the first rung here. And I'm going to click one time. When I do that, it's going to ask me, it says, hey, look, I see that your spacing is 0.5. The database might have been 0.75, might have been 1.0, who knows what it was. But it kind of self-selected and said, I see your database is 0.5. Do you want to use that? Well, of course I do, because that's what I set my rung spacing up as. I'm going to hit OK. And it's automatically going to set this up for you. Now, what you do need to do is you do need to give it a module number. So if this was, let's say, module 1, I hit OK. And you also need to give it a beginning address. Now, typically in the world of Allen Bradley, if it's module 1, it might be I:1/0 or something like that, right? So they give you a bunch of quick picks in here. If you're not sure what to use, they give you a bunch of quick picks. I kind of like this I:1/00. It's 16 inputs, so 00 being the first one, 15 being the last one. I'm module 1, so I'm just going to, if you had 16, if you had 10 or more modules, you may want to use 2 digits on the slot number. So I've got the input : slot/bit. I'm going to hit OK. When I do that, it's automatically going to go in there and it's going to populate it out for you. Now the neat thing about this, and it's also going to ask you though, it's going to say, hey, after input 17, what do you want the addressing to follow? It might be that you want the addressing to follow a decimal scheme, a octal scheme, or a hexadecimal scheme. I'm just going to go decimal. It'll just keep counting. I'm only going to get 16 of them anyways. So there I get it now. And what's going to happen is I come in here, boy, I'll tell you, pretty fancy. In 0 goes to I:1/0. And in 15 goes to I:1/15. And I can see my comms are set in here too. I've got a DC common for the first half of my inputs, and I have a DC common for the second half of my inputs, which would follow exactly what the 1769 IQ16 module would look like in real life. It tells me it's 24 volt DC, 16-point syncing input. Now, the one thing I don't like about what I did here was I ended up with all this extra junk down here, right? So what I could do is I could go ahead and highlight that stuff. And remember, if I highlight it with the blue, it's not going to select things that it just touches. It has to be fully contained. If I highlight it with the green, anything it touches, including that module up there, is going to get deleted. So what I want to do is I just want to delete this stuff down here. So I'm going to hit the delete key. Now you might say, wow, my rungs are too long now. Okay, fine. Just drag those things up. Drag them up and put them where you want them. You just got to kind of click on it and drag it up to where you want it and click again. And now I can see I have a really nice drawing of what this DC input module is going to look like. If you want to, you can also include, by clicking on the address, double click on the address, you can include descriptions, or you can put a tag value on this thing as far as whatever you want it to be. So maybe this, I think this description A, maybe I call this a stop PB. And I hit apply or OK. And then I can see stop PB kind of showed up over here. I don't know if I necessarily like where it showed up. I could move those around if I wanted to a little bit. But I can see stop PB is over there, and it's available to me now, right? And also where that module is too may or may not make more sense. I'm wondering if you can, I think you could scoot this thing, to be honest with you. Let me go scoot. Oh, no, I don't want to do that. Ooh, it looks like it's trying to scoot. Ooh, I'm not going to do that. I'm going to escape. That looks a little dangerous. But you get the idea that you can actually scoot that thing around and move it around. You know, maybe I want that stop PB to, try it one more time. What happens if I hit there? Yeah, my stop PB came over. If I right click again, go to scoot, I moved a little further than I would have liked there. It's a little funky because when you do this scoot, You're doing it for all the stuff. And we do it for all the stuff. The module is actually the left thing I'm moving, and those descriptions are the right thing I'm moving. So now I can see that that stop PB is in a good spot here where I kind of like where it's at. All right. The next thing I'm going to do is I want to add some of those little tails that we've used in the past here. I thought they were under miscellaneous. Yeah, the wire arrows for reference only. So I'm going to go ahead and go into here, and I'm going to bring in a tail up. I'm going to place that guy right here. I will tell you, be careful. I've noticed on some of your homeworks, you're not actually putting those on the actual diagram. It's important that we actually put those on the diagram. So I want to put in plus 24 VDC. And when I zoom in, I can see it is actually connected there. What I've seen some people do is they go to insert that little reference arrow. Again, it's under miscellaneous here. Reference arrows. I want the tail up. And I sometimes see people doing this. And they end up with something where it's not quite on the line there, right? It's not a problem. I mean, you can fix that fairly easily, but I'm going to call it 0 volt common. But I want to make sure that thing is actually touching, making connection there where I want it to connect. Much easier actually to just go ahead and on the icon menu, just reinsert that thing. Where is that? Miscellaneous, wire arrows, tail up. And just when you insert it, make sure it's connected. And then your 0V CMN, something like that. So that's how I'm going to real quick and easily get that IO module in there. And now I can see exactly what I'm looking for. It looks sharp. Everybody's happy with this. The next thing we're going to do is a little bit different, though. What I want to do is I want to go to the Rockwell Automation website. So let me pull this in real quick here if I can. Rockwell Automation website. I'm going to pull this across. So hopefully you guys can see what I'm looking at right now. So the Rockwell Automation website, if I click on it, it's rockwellautomation.com. And in here, there's all kinds of stuff, right? This is their landing page for Rockwell Automation. So you can get stuff on sales and the company and support and products and capabilities and industries. I mean, this site is huge. I'm going to go to support. And underneath support, I'm looking for some place where I'm going to be able to get 2D and 3D drawings of components. So as an example, if I go to, it's not under product support, I'm looking for 2D, 3D, documentation, I don't see, that's probably it. Product drawings and wiring diagrams. So if I click on product drawings and wiring diagrams, the nice thing is when I come in here, I can search by catalog number. So going back to my AutoCAD electrical drawing, I can see my catalog number was 1769 IQ16. If I go back to the web page I was just on, I can search for 1769-IQ16. And when I do that, it's going to actually give me a whole list of stuff on that particular product. First thing it's going to tell me is it's a 16-point 24-volt DC syncing or sourcing input module. I can click on product details. I can get a 3-dimensional model. I can get a 2-dimensional model, selection guide, wiring diagram. All that stuff is available, which might actually come in handy, right, if I wanted to give some directions as to the wiring. This DWG is actually probably an AutoCAD electrical drawing. Let me just pull it in once here real quick and see what this pulls in. So this pulls it in kind of it's not an AutoCAD electrical drawing per se, but it is an AutoCAD drawing that's opening up in AutoCAD electrical. I can say it's not an AutoCAD electrical drawing because as I click on things, I can see that limit switch isn't connected there, and they're just kind of hobbled together. But the nice thing is that's kind of handy, right? It's kind of handy to see how this thing would get wired up. But better than that is on the Rockwell page, there's also 2D dimensional drawing. And I can go grab this guide. He'll also open up in AutoCAD Electrical. And the neat thing about him is I could go ahead and just grab pieces of this that I want. Maybe I like the view of this module right here. So I'll highlight it in blue, I'll click, and I'll go to my clipboard and copy it. Now I'll go back to my original drawing. And on my original drawing, maybe I want to paste this thing in here. I want somebody to have a a picture of what that Allen Bradley module is, right? So they've got a picture of that Allen Bradley module. I thought there was a spot in here. I could be wrong. I guess I am wrong. I thought there was a spot in here where they actually give you a nice little isometric view and top, bottom, side. So you get a lot of views. But maybe I also want on here, maybe for some reason I thought this was handy too. So I want to include this. I think I'm going a little bit over the top here right now, by the way. I don't think I'd ask you to do all of this on your drawing. But now, real quick and easy, I can see, woo, so there's a problem here, right? The scaling of that drawing that they give you here is a monster. So this is not necessarily something I think I want to try to use. But you know, I potentially could place it in here and I might be able to resize it or something, but just looks like more than what I'd want to use. So right now I've got a nice view, really nice view of how this thing is going to work, right? I can see, and at this point, I can start plugging those same components we've used in the past, right? So my normally closed stop push button could go here and could be PB, I guess it's PB11, this is my 11th rung. I can maybe put a start push button down here. My normally open will go right here. If I wanted to, I guess I might have hit, what did I hit there? Did I hit OK repeat? Nope, this is it. I could hit OK repeat. No, I don't want to do that though, I don't think. Oh, let's try it once. Let's see here. Yeah, icon menu. Let's go to switches again. Let's go to switches. Do I have a single pull, single throw? I got contact switches, fuses. Got my push buttons. Not going to have any lights in here. Limit switches. Maybe I throw a limit switch in there. That's kind of nice. There's a couple limit switches in my system. I wonder if I hit OK repeat. Yeah, if you hit OK repeat and you're doing a bunch of limit switches, you can just continue to place them in there. And if I want to hit cancel, I can cancel out and I'm not doing any more then. And if I want to do other things here, let's see, besides limit switches, we got miscellaneous switches. There's our foot switches. There's a toggle switch. That's what I was looking for before. So I'll throw my toggle in there now. I'll repeat and throw a couple more in here. Now it's very important, in addition to, that'll be my last one, I think. In addition to, you know, making sure that your little arrows, your reference arrows are connected, another thing that you want to make sure you do is in this particular case, I'm only using 8 of the inputs here, right? If I'm only using 8 of those inputs, it might be very important, right, to not show these other inputs as wired up. Now it's going to default showing them wired up. The nice thing about that is when you go to put your component on them, you don't have to, like if I want to go grab a float switch now or something, right? If I want to go grab a, yeah, here's a float. If I want to go drag that, I don't have to wire. All I have to do is place on the wire, and it's in there. But the problem is it also defaults to this, and now you've got these wires that aren't hooked up. If I want to get rid of those rungs or those wires, I can't do it with a top left to bottom right click because that's a blue selection menu. I can do it with a bottom right to top left because when I click on that, anything it touches is going to get highlighted, and I can hit the delete key. And now I might even go so far as to click on these and call these, like under description, I might say unused. And I could do that for all of these, right? You know, I could click, or I might just do it for one of them, and we can just make an assumption that everything below I:1/9 is unused in our particular example, which seems to work for me. I'm going to close out of this one because we didn't use it. I'm going to close out of that one because we didn't use it. I do want to show you one other kind of interesting thing. You may run into an issue where this is great, and I could even take this. I hope I could take this. I could even maybe take this whole thing, and I could copy this. And I wonder if I could open up the 80 template. I think my template, I'm a little worried about the size of my template here. But yeah, that's what I was a little bit worried about this actually. But template's a little bit too small. I could. Well, I don't want to rotate it at this point, but you get the idea there as far as what we'd be working with here. I don't know that I want to delete. Yeah, that's a little bit of a mess there. And I'm just trying to see if there's anything else I could do to make that fit better. I don't know if perhaps when we submitted this guy, if we would have done, instead of 0.5, maybe we would have done 0.4 spacing and drawn our 20 rungs. And then if we would have done the same module, 1769 IQ16, what I can see right now is that actually with the 0.4, I'll call this module 2 just for the sake of argument here, and I don't care about, I'll just do the quick pick here. I can see by doing that, I actually would be able to fit this. Ooh, did he not like it? Oh, you know what I didn't do? Sorry about that. I'm going to undo that real quick. I don't think I did the spacing on that one. Let me just try it one more time here. 1769 IQ16. Did it give me a chance? Yeah, 0.4. Insert all. Yeah, there we go. Module 2. And I'll get my quick pick. That's what I was expecting to see. The only nice thing about this is by doing this one, what you'll see is if I wanted to use this in here, I'll grab my green one here real quick. There we go. If I wanted to put this one in there, I actually could fit this one in there. Meaning I can move this whole thing in here, and this guy would actually fit. I may want to, I may want to get rid of some of the stuff down in the bottom first, and even move up my my rails here a little bit. But I can see now that all of that stuff, oop, that escape. There we go. But now I can see that that would actually fit into my template now, and I wouldn't have to feel bad about the way my template looked anymore. So when you do your homework, spend a little bit more time crafting this thing up and making sure that your template is fairly fitting to what we're trying to do here. But you guys get the idea there. And again, I can go right back in here and I can start dumping components in here. If I just had 2 inputs as an example, maybe there's a couple normally closed buttons. I'll repeat a couple here. You'll notice I had one that didn't go in there. It does help if you zoom in on some of this stuff so you actually can see, did that device actually get put in there? And sometimes it's just easier just to go ahead and grab it again. Maybe there's a normally open here this time. And I can see them all in there. And again, if I want to get rid of the rungs that I'm not using, that drag can allow me to get rid of those really quick. Now let's say that for some reason you're in a drawing now and you don't want to use, or maybe there isn't a canned PLC IO that you can use. So the database doesn't exist. It's a brand new PLC. It's a really old PLC. Whatever the case may be, I'm going to insert the ladder diagram, and I'm going to go back to my 0.5 that I was using before. I probably should use, well, it doesn't make a difference. I'm just going to do it in here. I'm going to create my ladder diagram. I'm going to zoom in on this thing a little bit. And what you have available to you is in the icon menu, there's a couple other options that you have. I got to remember where these are at now. Under NFPA symbols, PLC IO, there it is. So under PLC IO, if you just want to do a one-wire first point in, you can do that. There's a one-wire first point in, and I could give it an address, I:0/1. Hit OK. And then I can maybe do another one of those. And I can do PLC IO, first point one wire. There's another one of these. And this will be I:1/ what was my last one? 1/1? Yes, or 0/1 is what it was. This will be an I:0/2. So now I have a couple PLC IO points there, and if I want to do an output, I can do the exact same thing. I go to PLC and I can go to one wire output. Now typically we're going to put these on this side of the drawing. And I'll call this O colon 2/1 as an example. I'll do one more, and I'll do a PLC output. Let's see right here, one wire, O colon 2/2. And now I can see I've got all of those in there. I might get rid of these rungs I don't need, so I'm going to do them in the green so I can just touch them. Might go down here and delete some of these as well. I got way too many rungs, by the way. So I'm just going to get rid of a whole bunch of these. Sure why that happened. That was kind of funky there. Let's do this. There we go. Now they're highlighting out. And so now the same thing, I may have to resize those rails. So I'll bring them up a ways. And I'll bring this guy up a ways. You see it tells you the degrees, so when you know when you're at 90 degrees, so you know you're keeping it perpendicular. And I don't know, maybe I have a couple more outputs in here. I'll just throw in a couple more outputs. I don't have to delete any more rungs here. So I'll grab one more output here, place it here. I'm going to do OK. I should have put an address on that, but I can do it after the fact if I want. Put one there as well. So this will be O colon. I did 1, 1, 1, 2. This will be 1 or 2/4, I think. And then this one down here would be 2/3. So probably the tag. Let's see. So now if you're not sure what tag that is, one of the things you can do is you can drill into one of the ones that is tagged, like this one here. And I can see that that value is tag A01 is O colon 2/1. So when I come into here, you're going to see there's lots of tags available, right? It was this one right here. So this is going to be O colon 2/3. And now it's going to tag in there just like the other ones. And just like I did with the other PLC, I can go ahead and place some components in here. I can place push buttons if I want. Switches. I'll just repeat a couple of these real quick. We do OK repeat, but now I'm gonna escape because I want to go grab a different device. Maybe I've got some pilot lamps that I want to get, some red lamps. They're going to go on the output side. Maybe another red lamp on the output side. Maybe there's a green lamp. So I'll go to, I deleted there too soon, but that's fine. I'll make the rest of the lamps green. Okay, repeat. Okay, repeat. Just so we can have something to look at there. And now this is where I might go back in with my icon menu, and I want to put in those leaders up in the top where I can label the voltage or something like that. Maybe in this particular case, maybe this is an AC. Maybe this is 120 VAC. I might put L1 on it. And I might on the other one here go to the icon menu and do another one of those. Under miscellaneous, wire arrow pointing up. And now this one's going to be neutral. And I'll call it L2. So now I've got my my neutral and my so there are obviously PLC modules out there that are AC modules, DC modules, relay modules, triac modules. There's thermistor or temperature sensor type modules. There's all kinds of modules out there that you may be dealing with. So hopefully that gives you the real basics on how to insert PLC IO into your diagrams. So let me go ahead and just take a look at the homework for this week. Homework 4, and I make sure I'm not opening up the wrong homework here. It sure looks like I'm opening up something weird. Boy, that's not going right. You do this, go over here. Open, please. Homework 4 is getting a little weird on me here. Let's close that out, reopen it. Documents A&T 32. That's that one. This one I'm going to close and go back into it from a fresh start here. I think we'll get into it this way. CAD Electrical homework. Let's get into homework 4, please. There we go. That's what I was looking for. So for homework 4, for full credit, 10 points. I am going to ask you to do this. Okay, and I think you can do this. I'll give you an example of what this first part is. We haven't actually done a lot of this yet, but let me show you what they mean here. So basically, they've set up kind of a power distribution system. So 243 in, we're sending that over to 120 in neutral, and then we're creating a power supply over here. So what I would do in this particular case, I'll just go into another drawing here real quick, is I would insert a ladder, but instead of inserting a ladder that is single phase, I'm going to insert a 3-phase ladder. And you can see in the homework, I kind of had it coming in from the top. So I'll do the same thing with this ladder now. I'll say, yep, I want a 3-phase ladder with 1/2-inch spacing. It's just going to kind of come in from the top like this is all it's going to do. And you might say that, okay, now what are those things? Well, it might be as simple as calling them L1, L2, and L3, right? So if I go into my miscellaneous and I go to my wire arrows, tail up, put one there, and I'll call this L1. Maybe I'll call it 240 VAC, and I'll call it L1. And I might not do the other ones. I might just, on the other ones, just call them L2 and L3, because I can see that it's then 3-phase power that's coming in. So the tail up, this one will be L2. And then the third one will be L3, of course. So I'll go tail up again. And the third one would be L3. So I've got my 3-phase power coming in, and then you would insert a transformer. And a transformer is really good at, taking 240 and making 120 out of it, right? So I might come find this transformer and say, okay, there's my transformer, and I'm going to say 240 VAC on the high side, 120 VAC on the low side. And then I might say, okay, I'm going to let me grab my wire tool. I'm going to run him over to L1. I'm going to run him over to L2. And now I can see where it's coming from. And I also can say, well, on the low side now, I got 120. So I might set the post here a little bit and just kind of go out and hit escape. I might do the same thing up here. Oops, wire. I got a little remnant of a wire there too, I apologize. And so like I can zoom in here, right? And I can see that little remnant of a wire. This is where that little green tool comes in really handy. Now it's gone. And on there I could do a reference, or I could do a tail. I could even use a tail going the other way, like we did the other ones there, where I could do a tail going generic arrow like this or something, right? And I could say, okay, there's that arrow, and maybe this is 120 VAC. And maybe the other one will be neutral. All of a sudden we've got kind of set up what we're looking for here. I won't spend a lot of time on this so you guys can have some time to work on the homework here. But there's neutral and there's 120 VAC. And now when you look at what you're going to do for the homework, I did ask you for a few other things, right? I asked you to bring in 2 more lines. And so what's going to happen is I want you to insert a disconnect here. I want you to feed the 3-phase onto the power supply using just a single, gosh, that's crazy. Using a single phase, so L1, L2 is feeding the high side 240. Out is coming 120. 120 in neutral, those lines are going over to 120 in neutral here. Then I want you to go ahead and find the icon for a power supply. I want you to put an earth ground on the power supply. I want you to put plus and minus coming out of the power supply, plus 24, 0 volt DC. So essentially you're building the power distribution circuit. This can be one drawing that you're going to do. So 243 phase, 3-phase disconnect, source and destination arrows, 120 VAC, 24 volts DAC, DC, text labels on each set of power rails, neatly print drawing using the AutoCAD template. So use the template, please. 11 by 17 fan fold when you hand it in, and the title block should show all those things. Then down here, I want you to do a PLC input module drawing. And so you're going to use a 1746 IB16 like we did in our example. I also want you to search for the DXF drawing. I want you to go out and find the DXF drawing. So it'll be very similar to what we just did. It's just a different module. 1746 IB16, these are the inputs I want you to include. I want you to include in 0 through in 11. I want you to show in 12 through in 15 as unused. And I want you to show that DC common going back. Make sure your rails are labeled plus 24, 0 volt. And again, this is on. So you're going to have two drawings this week. One that's showing a general power distribution. Where's the power coming from? The other one, how is that 24 volts being used on a PLC input module with all those PLC IO points? So I hope that's a good assignment for this week, and I hope that this this short lecture, this demo, by all means, rewind this, go back and watch it again. If you have questions, you can email me, Teams message me, but you can also put a question on YouTube, and perhaps some of your classmates may answer that question as well. Thank you for your time.